Hello, HIMARS friends. Today we are going to do a capacity test on MB and Oxy. First of all, we like to measure the individual cell voltages. The battery was charged last night to 14.2 volts and top balance already. So this morning, let's measure the individual cell voltages. The first one is the cell number 1, the one closest to the output terminal. So the first cell is 3.513 volt, and second cell is also 3.513 volts. The third cell, 3.513 again. And the fourth cell's 3.513. Yep. 513, 514. So the cells are perfectly balanced, and the total battery voltage is going to be 14.05. So the battery voltage is 14.05. So now the cells are measured and they are perfectly balanced. Let's start doing the test. And before we do any tests, let's cover this up for safety reasons. And these are my equipment. This is a 1 kilowatt charger, and this is a 100 amp shunt watt meter, and then we have an inverter, a 1.5 kilowatt inverter, and this shunt is 200 amp shunt, and I have a 150 amp circuit breaker, and then also a smart watt meter. So first of all, let's turn on the charger to simulate the kicker battery. So let's turn on the charger. Okay, the charger's on, and as you can see, the charger now is producing a 14.24 volt. No currents yet. So the current is 0. So let's turn on the battery. So we got blue light. Unfortunately, we don't have a clunk. And for some reason, it takes a while for the clunk to start. And now the charger is charging the charge side by 0.07 or 08 amps. So after a while, when the capacity in the charge side is charged up, then we should be able to hear a clunk. And once we hear the clunk, then we know the charge side contactor is closed, and then we could do a reset and close the discharge side. So since the charger is capable of about 60 amps, so I have 2 of the number 8 cable in parallel going to the charge side, and for the negative side, I have 4 of the 12 gauge wire parallel going to ground. So instead of waiting, okay, I hear a little small clunk a small click by a driver. So we should be able to hear the big clunk soon. And oh, actually it's already closed because we are charging right now at 7 a.m. So the charge side is already closed because I put the covers on and did not hear the clunk very loud. So I'm going to turn off the charger. So now the charger is turned off and the battery voltage is 14.15 volt and 0 amp is not charging. Now I could turn on the discharge side. Okay, the discharge side is on, and now this is the discharge watt meter, and it's 14.11 volt, 0 amp, and the most important number we are looking at is the bottom number, which is cap. Right now it's 0 amp hour because I resetted it already. So now it's producing, right now we're not drawing any currents from the battery. So let's turn on the inverter. Okay, the inverter is on right now. And the inverter itself is drawing 0.58 amp. So that is the overhead of the inverter. 0.57 amp. And the low we have is a heater. This heater is about 1500 watt, but I'm going to just use half of that. So I just use half the heater. I turn on the heater. Now the heater is going, and right now the heater is drawing 66.7, about 67 amp. So now the heater is on about 67 amp, and the power is about 885 watt for the heater and the inverter combined. So the battery voltage is drawn down to 13.27 volt. So this should take about 3 hours to discharge a 200 amp hour battery. So we'll come back in about 2 or 3 hours. Hopefully I could catch it before it goes offline. But if it does go offline, we already have the amp hour recorded. And my plan is to draw down the battery until the HBMS shut it down completely. Once the HBMS shut it down completely, then we know what is the low capacity of this HBMS. So we'll come back in a little while. Okay, I'm back. This is about 2.5 hours later, and the battery voltage is 12.41. It should trip around 12.4. So I just start recording to record the event when the HBMS decided to shut off the EcoTrack battery. And so far, the capacity is 157 amp hour. The rated capacity is 200, but in order to get to 200 amp hour, the EcoTrack battery has to draw down to maybe 10 or 11 volt, but the HBMS would not allow it. So there'll be some residual energy in the battery when the EcoTrack decided to kick it off. So it's still on and discharging. and the DC power is about 800 watt. But the AC power is only 750 watt. So which is consistent because this is a 1500 watt heater. I have half the heater on, so it's 750 watt. But because of the inversion inefficiency, so it takes 800 watts to run the heater, DC power, 800 watt DC power. So now the voltage is 12.35. This is the, oh, it just tripped, I believe. Yes, it just tripped. So it was tripped at 12.35, but the battery voltage rebounds back to 12.58. So it's good that we capture the tripping. So I'm gonna wait for an hour for the battery voltage to settle and then come back to measure the individual cell voltage and also start the recharging process. See you later. Okay, I'm back. It's been an hour later after the EcoTrack shut off discharging at about 12.35 volts, and the discharge rate is approximately 0.3 C because the discharge current was about 65 amps. And I measured the individual cell voltages from cell 1 to cell 4, 3.177, 3.185, 3.164, 3.186. So that all add up to, again, 12.71. So the battery responds back quite a bit. And the cell imbalance is 22 millivolt. When it was fully top balanced, when the charge was full, there was no imbalance. Now the imbalance is 22 millivolt, which is not bad at all. That's a good indication that the individual cells are pretty good. Since the voltage is at 12.71 volt, I'm hoping that I could restart the battery without turning on the charger yet. So let us try. Yay, it did. I hope you heard the click sound. So the battery is restarting, and as you could tell, the discharge panel come back on, and the voltage is about 12.72, 12.24. Yeah, it jumps around a little bit. The total discharge earlier was 158.41 amp hour. So at that energy, the BMS cut it off. So now this is the charging meter, and 12.73 volt is the battery voltage. It varies slightly with my more accurate multimeter. So I'm going to turn on the charger now and get it to recharge 100%. Okay, the charger just got turned on and is charging the battery at 65 amp. Again, about 0.3 C, and the total charge power is 885 watt, and currently the charging energy is 8 watt hour. So we'll come back, or at least I will come back later to check on charging. It should take about 3 hours to charge up the battery, because this is charging about at 0.3 C. And when it's fully charged, the current should be down to 2.5 amp. The 2.5 amp is really the standby current or the overhead used by the H-EcoTrack. And hopefully the cells are still in balance. If the cells are not in balance, it might trip charging before it gets the full charge. But we'll see. If the cells are nice and balanced, then we should be able to charge it back up to 14.2 volts. And with the steady state overhead currents about 2.5 amp, that would take 3 to 4 hours. Okay, after 4+ hours of charging, finally the battery is pretty much at full capacity. You can see there's still a 2.5 amps of current going through the battery. That 2.5 amp is really used to support the overhead of the HBMS. So we could shut it off and do the other battery, and the final energy is 2343 watt hour. Here is a recap and summary of all 3-part EcoTrack lithium iron phosphate battery restoration effort. The first battery was named MB because of its cell imbalance problem. The second battery was named Oxy for its oxidized and corroded terminals. It is not clear to me why the negative ground reference wire to the HBMS was connected to the heater pad negative instead of the cell 1 negative. That arrangement created an 80 milliwatt artificial imbalance between cell 1 and the other 3 cells. The first 2 videos show the correction of that and the installation of a 5 amp cell balancer. The third video showed the full energy discharge and charge of MB. The same was done with Oxy, just not captured on video. Both batteries were top balanced prior to the capacity test, meaning same 3.65 cell voltages at full charge. At the end of discharge, the battery was slightly out of balance, with MB at 22 millivolt and Oxy at 35 millivolt, which is not unusual. Based on the test results, it was estimated conservatively that both batteries still maintain at least 90% of their 200 amp-hour energy capacity. Not bad for a 3-year-old H-vintage EcoTrack with 18,000 mile usage. The charge side contactor would not engage until 75 seconds after the EcoTrack switch was turned on, because there was no kicker AGM connected to ChicoCharge, a large time constant RC charge affirmative circuit. During that time, the power supply was providing 70 to 300 milliamp to the charge side terminal. We are so used to the EcoTrax being maintained by the kicker in our camper that only takes a couple of seconds for the charge contactor to engage. INBI appeared to be in good shape with both the cells and the HBMS. Oxy is a different story. Its cells are good, but the BMS is iffy. As soon as I turned on the switch, there was some faint cyclic sound coming out of one of the small relay coincide with the 300 milliamp higher current draw. Then the sound stopped and the current dropped to 70 milliamp, just like INBI. Then a moment later, the charge contactor would engage. Oxy behaved normal during discharging. However, during charging, its discharge contactor would drop out randomly multiple times. Pressing reset would get it engaged again. Well, that wraps up the EcoTrax restoration project. While INBI is in good working order, unfortunately, Oxy may have an intermittent relay driver board malfunctioning problem and could not be restored to 100%. Thanks for watching.